So, good afternoon or good morning, depending on where you are, and welcome to our webinar on Longlife preparative scale column hardware. My name is Guido Krautz. I'm the Business Development Manager at Dr. Maisch, and I'm your host and speaker today. Before we start, I need to make some organizational announcements. First of all, according to GDPR guidelines, I need to inform you that this webinar will be video recorded. Your names will not be visible to other participants throughout this presentation, but they will be visible if you ask questions during the question and answer session. Your microphones will be muted during the presentation. We will have a question and answer session at the end of this presentation, and you have two ways to ask questions. Please do not use the chat function because this is disabled. If you would like to ask a question in writing, then please use the question and answer icon at the bottom of your screen. And if you would like to ask a verbal question, then please raise your hand. There's another icon at the bottom of your screen, and I will unmute your phone. All right, so let's get started. I will share my screen now. Okay, once again, this webinar is about Longlife, which is our brand name for our preparative scale column hardware by Dr. Maisch. Before we jump into the topic, please let me briefly explain who we are and what we do. So Dr. Maisch HPLC is located in the south of Germany in a high-tech hotspot near the city of Tübingen, and that again is near the city of Stuttgart. The Dr. Maisch brands have enjoyed an increasing market recognition over the last years. Our two main brands are ReproSil, which was launched in 1996, and ReproSphere, launched in 2003. And you can see this by the number of publications after the launch of these media. We had an expansion of our facilities in 2019 and 2020. The two buildings here were the existing ones, and we have added this new complex here, which adds 900 square meters to our facilities, and that's 300 square meters of silica gel production and modification. So this is an expansion of our facilities in the UK, and 150 square meters of R&D, and we have also expanded our column packing capacity. We are proud to rely on local excellence to serve international markets. So we control the full value chain, starting from silica gel production, surface modification, hardware manufacturing, and column packing. And if we don't make things by ourselves, such as steel tubes for our hardware, we source them from local suppliers. There are two core expertises at Dr. Maisch. First is silica gel development and production, and we have done that for 20 years. So we make our own silica, we do the surface modification in-house, and then we pack these media into column hardware, analytical, prep, and process skill. The second core expertise at Dr. Maisch is the design and manufacturing of column hardware and the packing of these columns. And we really do everything from capillary scale, nanoscale columns, all the way up to process scale columns, such as the one on the right-hand side, which is now our biggest column. It's a 200 millimeter ID column, but we are working on a 300 millimeter column as well. And because we work with local suppliers, we can do custom sizes. We have done columns up to a length of 1.2 meters. So today we will talk about our hardware, our prep hardware. And this page gives an overview about different types of hardware we supply. First, there are standard threaded and standard flanged hardwares. So these are cost-effective, high-quality hardwares, which are fixed bed columns. I will explain what that means later. Today, we will mainly talk about Longlife and Modcall. So in contrary to these standard columns, these columns are packed with a piston, and we have patented this technology. So these columns offer analytical-like performance and, as the name suggests, an increased lifetime. So we can distinguish between two types of columns: fixed bed columns, which are packed by a solvent flow, and columns which are packed with a piston, so-called axial compression columns. And within the second category, there are columns with a static piston. So the piston cannot move, it's fixed. So it's a static axial compression column, or the piston can be dynamic, then it's a dynamic axial compression column. So in order to explain why we developed this Longlife hardware, let me first explain how traditional columns, so these fixed bed columns, are packed and what the problems are which relate to this way of packing columns. So what you see on the left here is the column body at the bottom and a packing extension, a packing reservoir on top. You need that because the slurry takes up a larger volume than the bed itself. So therefore, you need to attach this packing reservoir to the column to accommodate the slurry. And then you pump a pushing solvent through the column so that the bed will be compacted. So once this is done and the bed is packed, you need to disconnect the packing reservoir from the column. And that means that at this time, the pressure is released. So if something was under pressure and then the pressure is released, this can expand. And this is exactly what happens. So the stationary phase expands, it extrudes out of the column. And then you have to remove this overhead here and close the column as quickly as you can. But as you see, you have lost some of the silica gel, which was previously in the column under pressure. And then you close it at ambient pressure. But after that, you will use the column again under pressure if you do chromatography. And that means that you recompress the bed. And then there is the possibility that you build a void. And this void can lead to decreasing performance. So as you see, there are several intrinsic problems related to this way of packing fixed bed columns. So let me repeat that. First of all, you need excess media, which ends up in the packing reservoir. And then there is a further loss of media related to the packing. And that leads to lower packing density and lower efficiency of the resulting column. Also, there's the possibility of bed disruption upon the pressure release. And there's a non-uniform packing density along the column length because there is a pressure drop from the top to the bottom of the column if you pack with a flow pressure. Furthermore, there is a possibility of formation of voids during the use of the column and therefore a limited lifetime. So in order to avoid this, you can pack a column using a piston, and this is what is done with the Longlife hardware. So instead of using a flow pressure, you use a piston to compress your column. And the piston stays in the column, so the pressure is not going to be released. So there is no extra need of media because everything you fill into the tube ends up as a column bed. And because you use mechanical pressure by the force of the piston, there is no pressure drop along the column. So the packing pressure at the top of the column and at the bottom of the column is the same, so you get a uniform packed bed. So as I've said, the piston stays in the column. The pressure is not released. So there is no way that the bed can get disrupted. There's a consistent packing density. There's no way that voids are formed, and this leads to an increased lifetime. So what is this long life column hardware about? So it's a patented hardware. It comes as a static axial compression column or as a dynamic axial compression column, and it's also suitable for SFC, or supercritical fluid chromatography. So it offers an extremely high performance, analytical-like performance, and lifetime. So how is that done? So the long life column hardware, the principle of this hardware, relies on the Modcall technology. So Modcall spring columns, that's a technology we acquired from Grace back in 2016. So these columns are called spring columns because they contain a mechanical spring. So this graph here illustrates how these spring columns are packed. So the whole thing here is the column plus the packing reservoir. So in case of Modcall, this is one piece. And then you compress the bed, as you do with dynamic axial compression columns. And together with compressing the bed, you also compress the spring. Once the bed is packed, you lock the spring in this position, but not in that position. So the spring is loaded and can expand once a void is formed inside the column body. So here, the dynamic axial compression mechanism is integrated into the column, and it will compensate any voids. So in reality, this looks like this. Well, not quite, because the Modcall columns are steel columns. So this is a plastic column, so you can look inside. What you see here on the left is the packed bed. This is the piston with the sealings, the O-ring. This is the spring, and this is the packing shaft. So the only wetted part of the column is this packed bed here to the left. So as you see, this column is quite long. The hardware is quite long. I mean, this is a particularly short bed. You can pack longer beds, but you cannot use the whole hardware length as a bed length, because all these things here need to fit into the column. And this can be a disadvantage because sometimes customers use a column oven, so this long thing doesn't fit inside. So we wanted to create a pre-packed column hardware with a normal length, so not much longer than the bed length. And that led us to the long life idea. So long life is packed in the same way as Modcall, only that we have chopped the column up into two pieces. So the lower part is the column body, and then we have again a packing reservoir, a packing extension here. So when we pack the column, we run the piston through the packing extension all the way into the column, and then the piston remains in the column. So now there comes a challenge. We want to remove the packing reservoir without releasing the pressure and without taking the piston out. So how can we do that? And this is what this patent is actually about. So this is the design of the column. These are the column walls. This is the piston inside the column. And these are spacers. So the spacers keep the distance between the piston and the end fitting. So these spacers are kind of half tubes. So this is the view from the top. This is the view from the side. So the end fitting is designed in such a way that it consists of two pieces. Here you see the picture from the top, and this is what it looks like in reality. So when we close the column, we lift up the packing reservoir, and then we can attach these end fittings sideways. So we don't have to attach it from the top. And this is how we close the column. So what you also see here is that we can insert tubes, half tubes, spaces of different length. So we can control the bed length. And if we use longer spaces like here, we can pack a shorter bed. So the bed length of the Longlife column is flexible. And then instead of using rigid spacers like these, we can pop in these springs. So these are not helical springs, but they consist of conical washers like this. And when we use pressure to compress them, then these washers go slightly flat. And this is how they store the force, the pressure. So when we use these springs instead of the rigid spacers, then we have created a dynamic axial compression column. So what are the technical options with Longlife? Longlife comes in various diameters, 25, 30, 40, 50, and 70 millimeter ID. The maximum bed length is 250 millimeter, but we can use shorter beds as well, because we can pop in these spacers. And very important, we can pack particles down to 3 micrometer particle size. As far as I know, Longlife is the only prep column hardware which can be packed with 3 micron particles. So Longlife is a pre-packed column. It can only be packed by Dr. Maisch. It comes as a DAC or a SAC version. Also SFC versions are available. And we offer packing service also for non-Dr. Maisch brands. So if you want another brand to be packed into Longlife, that's not a problem. We also offer a repack service. So Longlife is not a single-use column. It can be returned to us for repacking either with the same media or another one, even to a different bed length. So now I want to show some examples of media we have packed into this hardware. So here are 2 chiral medias, ReproSil chiral MIA. So that's the alternative to the immobilized chiral pack IA. 5 micron packed to 86,000 theoretical plates per meter. And ReproSil chiral NR, this is a unique phase from Dr. Maisch. It's a brush type phase, 8 microns packed to an efficiency of 55,000 plates. As I said, we also pack media from other manufacturers. So here are 2 examples of Adsorbosphere media and a column we packed with Luna C183. So this is a 10 micron material, and you see you get just under 40,000 plates, and that's what you actually expect from a 10 micron material. I want to come back to the possibility to pack 3 micron particles. As you probably know, coreshell particles have been pushed by particularly one company as prep columns. And here I want to compare the performance of coreshell particles with fully porous particles. So let's compare the surface area and the column efficiency. So coreshell particles, because of their non-porous core, have a rather low surface area. So the surface area is about 100 square meters per gram, while a fully porous particle, such as our ReproSil Pure Basic 3 micron, has a surface area of 450 square meters per gram. You cannot compare these numbers directly because these 2 types of particles have different densities. So we want to convert this into square meters per milliliter, because this is what you actually care about, your surface area in the column. And the column has a certain volume. You don't care how about the mass of the media you have inside. So coreshell particles have a density of roughly 1. So 100 square meters per gram equals 100 square meters per milliliter, while fully porous particles have a lower density. So 450 square meters per gram converts to 270 square meters per milliliter. So what you see is, even taking into account the different densities, coreshell particles have a lower surface area than fully porous particles by the factor of 2.7. Well, we are comparing 5 micron with 3 micron particles. As we all know, coreshell particles have a higher efficiency compared to fully porous particles of the same particle size. So the efficiency of a fully porous 3 micron particle is similar to the efficiency of 5 micron coreshell particles. However, you pay a price for that, and that price is called pressure, because 3 micron particles cause a higher pressure compared to 5 micron by the factor of roughly 2.7. So what you see here is you have a 2.7-fold higher surface area, but also a 2.7-fold higher pressure. But we have a margin here. We can reduce the column length by the factor of 2.7 and still end up with the same pressure and the same surface area. And especially when you do SFC, pressure is not that important. You don't have problems with the back pressure. So we really push and recommend these long life columns packed with 3 micron for SFC applications. So here's an example of a 3 micron particle packed in an analytical column. In this case, it is a reverse phase media, ReproSil Pure Basic C18, 3 micron, and the 250 by 50 millimeter column, a prep column. And you see that you end up with virtually the same analytical-like performance in the prep column. So here are another 2 3 micron media, and these are recommended for achiral SFC. There is our 2EP, which stands for 2-ethylpyridine, and our PEI, that stands for polyethyleneamine, and both phases are really popular for achiral SFC. And you see that we get really high plate counts here, even in the prep columns. So another important aspect of long life is that it can be repacked, as I've mentioned before. And that's important because often column hardware represents a significant part of the column value. So I've broken it down here. Let's look at the ReproSil Pure Basic C18 column, 10 micron, packed in a 250 by 50 millimeter hardware. And the hardware itself already represents 50% of the value of the whole column. So every time you send back your column to Dr. Maisch to have it repacked, you're saving money because you already own the hardware. You don't have to buy it again. So you buy the hardware at the first time, and then the second, third, fourth, fifth time, you only have to pay for the media and for the packing service. So over time, your average price decreases. So to summarize some of the benefits of long life hardware, and I compare it with the Axia hardware from Phenomenex and the OBD hardware from Waters. Among these three, only Long Life and Axia are packed with a piston. OBD is not. The bed length is flexible, only with the Long Life hardware. And only Long Life is a dynamic axial compression column. And it's the only column of its kind, the only pre-pack column on the market. We offer packing and repacking service. So that means we can also pack media from other manufacturers. And we have 2 additional sizes, namely 40 and 70 millimeter ID. If you want to use a larger hardware, if you want to go beyond 70 millimeter ID, then there's always the option to use our Modcall spring columns, because the way how to pack them is the same as Long Life. And with Modcall, you also have the option to pack your columns in-house. Sorry, So to summarize, Longlife is available as a dynamic axial compression version and as a static axial compression version. It comes in different diameters, namely 25, 30, 40, 50, and 70 millimeter ID. The technology of packing these columns is similar to Modcall, but the packing reservoir is taken apart. So the whole column hardware, the whole column is shorter, and the piston stays inside the column. So you will see extremely high performance and stability. And this is a pre-packed column hardware, so it can only be packed by Dr. Maisch. So I want to show you some Modcall columns. So since we acquired this technology from Grace in 2016, we have added more dimensions to this portfolio. So what you see here are the 25, 50, and 100 millimeter ID columns. And we have recently added a 150 millimeter ID column, and that's the one here on the left and on the right. So these Modcall columns can also be supplied as pre-packed columns by Dr. Maisch, or if you decide to buy the MultiPacker, which is the device to pack these columns, you can pack these columns in-house. So there are two models of the MultiPacker, the smaller one, which packs all the dimensions from 25 up to 70 millimeter ID, and the larger one, which looks like this, which packs all the dimensions from 50 millimeter ID up to 150 millimeter ID. So there's one more hardware, which also contains a piston, but it's a static axial compression hardware. We call it manually adjustable column. The design is like this. This head, this column head here, is flexible. So there is a gap of 15 millimeters. And you can turn the column head and thereby drive the piston down. So this does not function automatically, so it's not a dynamic axial compression column, but you can manually readjust the piston if you notice that a void is formed in the column. And that column comes also in larger sizes. So this is a 10 centimeter ID column, and we have designed a 20 centimeter column like this, which has 4 screws here at the top to recompress the bed. That can also be dry packed with larger particles. It can be slurry packed. And this has become quite popular for the purification of cannabinoids in medium pressure chromatography. So together with our column hardware, we also supply guards up to a size of 30 millimeter ID. These guards are based on the Cartridge system. So here you see a 30 millimeter ID guard cartridge. And these can be used for columns up to 50 millimeter ID. In order to compensate for the extra back pressure this will cause, so using a 30 millimeter ID column with a larger prep column, you can reduce the particle size of the media which you use inside. So if you use 10 micron instead of 5, you have compensated for this extra back pressure. And we supply guards also for our prep columns. So this doesn't really look like a column, but it is. So this is a 10 centimeter ID guard column packed to a length of 5 centimeters. So with that, I have finished my presentation. I thank you for your attention. And now I invite you to ask questions. So has anyone got a question? I see there's a written question here. it says, with the DAC system, the height of the bed can decrease over time. So N is decreasing. Oh, you're talking about the efficiency. I see. Yes, the bed can settle over time. That happens particularly at the beginning when a column has just been packed. But that doesn't mean that the efficiency is decreasing. Because when you compact the bed, the efficiency can even increase. There's another question. Is it possible to pack Longlife column to 20 millimeter? I'm not sure if I understand the question correctly. 20 millimeter, okay, 20 millimeter ID. No, there is no 20 millimeter ID column hardware. So the smallest column starts with 25 millimeter ID. Are there more questions? You can also ask a question verbally by raising your hand. There's an icon at the bottom of your screen. All right. Any more questions? Oh, there's another question. What is about column max pressure, Modcall, and Longlife? Okay. First of all, Modcall, the pressure this MultiPacker can generate, the maximum pressure is 138 bars. So this is the maximum pressure with which you can pack the column. And if you pack it as a dynamic axial compression column, then this is also the maximum pressure you can use during your chromatography. You can also pack Modcall columns without the springs, then it's a static axial compression column, and then you can use them up to 200 bars. So the Longlife column hardware can be packed at higher pressure. So the maximum pressure here is also 200 bars. Are there more questions? Here's a question, are your guard columns SFC compatible? Yes, they are. Another question here, how long does it usually take to pack a column? Are you talking about the lead time or the actual time it takes really to pack the column in the lab? I mean, packing a column is probably a question of half an hour. If you're talking about lead time, if we're talking about a packing service, then as soon as we have the order, as soon as we have the media, we're talking about 1 week, maximum 2 weeks. All right. I'm waiting for more questions. Another question here, what is the maximum operating pressure for your column? I think I answered the question already. So if you use the column for example, the Modcall column as a dynamic axial compression column, then the maximum operating pressure is the packing pressure. So you should not exceed 138 bars. If it's a static axial compression column, then you can go up to 200 bars. All right. Any additional questions, please? Yes, there's one more question. Do you have chiral material also in 3 micron? We have some media in 3 micron. We have tried to pack 3 micron particles into our Longlife hardware, but we still have to optimize the process because right now we don't get the efficiency which we would expect from 3 micron. So in principle, it's possible, but we still need to work on the packing conditions. Okay, I'm waiting for more questions. Okay, if that's not the case, then I thank you for your attention. And I will close this webinar. If you have questions coming up later, you can always write an email to me. My email was mentioned in the confirmation which you received. So thank you for your attention, and I wish you a good afternoon.